a telescope that was meant to become humanity's most perfect eye. A project that cost billions, created by thousands of people who spent years refining every detail. When it finally reached space, it was supposed to show the universe in a way no one had ever seen before. Instead, the images turned out to be blurry. There was no doubt that something had gone wrong. This was not a minor imperfection, but a flaw that could have ended the entire project in disaster. This story is not about perfect technology. It is the story of a mistake that almost erased years of work, and at the same time sparked one of the greatest revolutions in our understanding of the universe. Observing space from the surface of Earth has always had one fundamental limitation: the atmosphere. The air above us is not stable. It is constantly moving, heating up and cooling down, causing subtle distortions in the light coming from space. That is why stars twinkle and why images captured by ground-based telescopes are never perfectly sharp. You can build larger and larger mirrors and better cameras, but the atmosphere remains an obstacle that cannot be fully overcome. For decades, astronomers tried to work around it by building observatories on mountain peaks and in remote, dry locations. It helped, but only to a certain extent. At some point, an idea emerged that today seems obvious. If the problem is the air, then perhaps the telescope should be placed above the atmosphere. The idea was simple, but its execution seemed extremely difficult. Delicate instruments would have to survive a rocket launch, intense vibrations and acceleration, and then operate in a vacuum where any failure could mean the end of the mission. For many years, such a project remained only a vision. Too expensive, too risky, and too technologically complex. And yet, over time it became clear that if humanity wanted to see the universe truly clearly, improving what stood on Earth was not enough. We had to look from above. The name of the telescope was not chosen by accident. Hubble was named in honor of Edwin Hubble, one of the most important astronomers of the 20th century. He was the first to provide evidence that the universe is not static. By observing distant galaxies, he noticed that they were moving away from one another, which led to the discovery of the expansion of the universe. It was one of those discoveries that permanently changed the way we think about reality. Naming the telescope after him carried symbolic meaning. As a scientist, Hubble showed that the cosmos is far larger and more dynamic than previously believed. The Hubble Space Telescope was meant to take that idea one step further and allow us to actually see it. In a sense, the telescope fulfills the vision of its patron. It looks farther, deeper, and more precisely than ever before, confirming that the universe is constantly changing and still hides more mysteries than we can imagine. Before Hubble, there were already scientific instruments in space. These were telescopes specialized in observing forms of radiation that cannot be seen from Earth's surface. Ultraviolet light, X-rays, and infrared radiation provided valuable scientific data, but for most people, space remained abstract. There were data and charts, but there was no image that could simply be seen and understood without diving into complex physics. Ground-based telescopes became larger and more advanced, but they still lost the battle against the atmosphere. There was always a point at which further improvement in image quality became impossible. That was when people began to talk about something more than just another scientific instrument. From the very beginning, it was clear that this was not meant to be an experiment or a small device, but a full-scale space observatory. A telescope that would observe visible light, operate for many years, and deliver images that would change not only science, but also the way people imagine the universe. It was a bold and risky idea. If something went wrong, the failure would be visible to the entire world. But that is precisely why the Hubble project was, from the start, something more than just another scientific mission. When the decision was made to build a full-fledged space observatory, real problems emerged. The telescope had to operate in a vacuum, under extreme temperatures, and without the possibility of easy repair. Every component required a level of precision that had never before been applied on such a scale. The project was expensive and repeatedly delayed. Questions arose more and more often about whether the risk was too great and whether the money could be spent elsewhere. Pressure came from all sides. Politicians wanted results, engineers wanted to perfect every detail, and scientists feared that technical compromises would later affect the quality of observations. It was in this atmosphere that crucial decisions were made, decisions taken at desks, in conference rooms, and during meetings that would later fly into space along with the telescope. One of them concerned the mirror, the most important element of the entire construction. It had to be perfect because in astronomy, even the smallest error can completely change the final result. At the time, no one knew that this very component would become the greatest problem of the mission, and that the consequences of one seemingly minor mistake would be seen by the entire world. The launch of the telescope was an event of enormous significance. After years of delays, technical problems, and battles over funding, the moment finally arrived when the project stopped being a plan and became reality. Hubble reached Earth orbit above the atmosphere, exactly where it was meant to finally reveal its full potential. The first days after launch were spent checking systems and preparing the telescope for operation. Everything appeared to be working correctly. Instruments responded, communication was stable, and the telescope behaved as expected. Nothing suggested trouble. But when the first images began to arrive, excitement quickly gave way to concern. The pictures were blurry. Details that should have been sharp and clear dissolved into light. At first, it was assumed to be a calibration issue or a problem with instrument settings. Such things had happened before and were usually easy to correct. Over time, it became clear that the problem was more serious. Further tests brought no improvement, and data analysis led to increasingly troubling conclusions. The telescope was working, but it was not seeing as it should. Worse still, everything indicated that the source of the problem lay at the very heart of the structure. Eventually, the worst-case scenario was confirmed. The primary mirror of the telescope had been manufactured with a slight error. It was so small that on Earth it seemed insignificant, but in space it proved critical. Light was not focusing exactly where it should, causing the images to lose sharpness. For the team responsible for the project, this was a moment of shock. A telescope that was supposed to symbolize precision and progress suddenly became an example of how a single small error could threaten an entire mission. The media quickly seized on the story, and Hubble began to be seen not as a breakthrough, but as an expensive failure. Then came the question that would determine the telescope's future. Could it be fixed? When it was confirmed that the problem lay in the primary mirror, the situation seemed hopeless. The telescope was hundreds of kilometers above Earth, and its most important component was not performing its function. Under normal circumstances, this would have meant the end of the mission. In Hubble's case, however, there was one thing that set it apart from all previous telescopes. It had been designed to be serviced in orbit. What had once been considered an extra precaution suddenly became the only chance to save the project. Engineers and scientists began working on a plan that only a few years earlier would have sounded like pure science fiction. A solution had to be designed that would correct the mirror's flaw without replacing it, and astronauts had to be sent to carry out the operation in open space. The problem was that the mirror itself could not simply be fixed. It was permanently mounted and far too delicate to modify. Instead, the decision was made to correct the path of the light before it reached the scientific instruments. In practice, this meant creating a system that worked like extremely precise glasses for the telescope. Every element of this solution had to be designed and tested with extraordinary care. Astronauts trained for months in pools simulating weightlessness, learning to work in bulky spacesuits with tools that behave very differently in space than they do on Earth. Every movement was planned. Every bolt had its place and order. The risk was enormous. A single mistake could have damaged the telescope beyond repair. On top of that, there was the danger to the astronauts themselves, who would spend many hours outside the shuttle performing complex operations in a vacuum. Despite this, the decision was made. Hubble would be given a second chance. The servicing mission was one of the most demanding operations ever planned. Astronauts carried out a series of precise spacewalks, working on a telescope orbiting Earth at tremendous speed. Every step had been scheduled down to the minute, because in such conditions there was no room for improvisation. During successive excursions into open space, instruments were replaced, and a corrective system was installed to compensate for the flaw in the primary mirror. The work was slow and exhausting. Thick gloves, limited movement, and the smallest error could have had serious consequences. Yet everything proceeded according to plan. After the repair was completed, all that remained was to wait. The telescope was powered up again, and scientists watched the first tests with tension. This time, the images were different. Stars were sharp, details were clear. It was a moment of relief, but also of immense satisfaction. Hubble was finally seeing the way it was meant to from the very beginning. From that moment on, its work took on an entirely new meaning. Every new image confirmed that the operation had been a success. A telescope once considered a failure began delivering images unlike anything seen before. Galaxies, nebulae, and distant star clusters appeared with unprecedented clarity. The repair of Hubble became more than just a technical success. It was proof that even extremely complex projects can be saved if they are well planned and if people are willing to take responsibility for their mistakes. From that point on, the telescope stopped being a symbol of failure and became a symbol of perseverance and courage in science. When the telescope finally began to operate as planned, it quickly became clear that its significance went far beyond a single successful image or individual discovery. Hubble began to systematically change our understanding of the universe, piece by piece, image by image. One of the first breakthroughs was the observation of very distant galaxies. Because light takes billions of years to reach us, Hubble showed the universe in its early stages. Suddenly, it became clear that we were not only looking across space, but also back in time. Galaxies that had once appeared as faint smudges revealed their structure, shapes, and diversity. Particularly important were long observations of small regions of the sky that initially seemed empty. Where darkness had once been assumed, Hubble discovered thousands of galaxies. This revealed just how unimaginably vast and densely populated the universe truly is. Each such image challenged intuition and forced a rethinking of how special or how ordinary our place in the cosmos really is. Hubble also played a key role in precisely determining the rate at which the universe is expanding. Thanks to accurate measurements of distances to stars and galaxies, it became possible to better estimate its age. What had once been a wide range of uncertainty began to narrow into concrete values. Equally important were images of the birth and death of stars. Nebulae that had previously existed, mainly in descriptions and simplified illustrations, became tangible. We could see matter gathering, collapsing, igniting, and then being scattered into space by supernova explosions. Processes that take millions of years gained a visual form. Over time, it became clear that Hubble does more than provide scientific data. It changes the way people think about space. Images ceased to be tools only for astronomers and became part of culture, symbols of human curiosity and proof that we are capable of looking far beyond the boundaries of our own planet. After years of operation, Hubble became more than just a scientific instrument. It became a reference point, something against which all subsequent telescopes and space missions are compared. Despite the passage of time, it still operates, still observes, and still delivers data used by researchers around the world. Although it is no longer the most advanced telescope, its role remains unique. Hubble observes the universe in visible light, the range closest to how we perceive reality with our own eyes. Thanks to this, its images are intuitive and understandable, even for those who are not professional astronomers. Hubble also serves another purpose. It is a chronicle of change. It observes the same objects for years, even decades, showing that the cosmos is not static. Stars evolve, nebulae change, and galaxies slowly drift relative to one another. This is a perspective that cannot be achieved through short, one-time missions. At the same time, Hubble became a teacher. Its history influenced the design of later space telescopes. It showed how important serviceability is, how dangerous seemingly small compromises can be, and how crucial thorough testing of every component truly is. Many decisions made for newer projects were direct lessons drawn from this single mission. At some point, the question of the end also appeared. Every satellite has its lifespan, and Hubble is no exception. Its instruments are aging, and its orbit is slowly decaying. One day, it will stop working. It will no longer send images that for years changed the way we look at space. But even then, its significance will not disappear. Hubble permanently changed astronomy and culture. It showed that failure does not have to be the end, and that a mistake can become the beginning of something much greater. Its true legacy is not only images and data, but proof that science is a process in which correcting our own errors is just as important as the discoveries themselves. If you found this episode interesting, leave a subscription and a comment. It truly helps in creating more content like this. And if you want more stories about space, telescopes, and the future of exploring the universe, let me know in the comments what you would like to see in the next episode.